Hello everyone. In this video we're going to have a look at the difference between the shallow copy and the deep copy operators. Now, when you are copying attributes that are pointers, okay, so this was the previous example that we used to illustrate the use of the copy constructor, but we made some modifications. Alright, so for example, let me just run through this code. We have a class of car public, okay, so we have a model and speed variables inside of it, okay, they are both uninitialized. Then we have the default the no argument constructor, and then we have the copy constructor and the class ends, and then we have the main function, and we have the BMW1 object, then we have the speed model and model2 variables. Okay, we can just go ahead and delete that for now. Then I have BMW1.speed, we're setting it to 230 dot model is 2015, and BMW2 is equal to BMW1. And for now, let's just do that, keep it simple. Then what we have is we have the cout, basically the show. Okay, so what we're going to do is print out the BMW speed, BMW's model, and then BMW2, which we copied over here. We created an object called BMW2, and we copied BMW1's attributes all into BMW2. Okay, then we're going to print out both of these. Now if I run this, alright, the way we run it is like this. First going to compile, and then we're going to run. So you can see that this is a normal copy constructor, it just copies one object's attributes into another. Now when we're using a shallow copy and deep copy, the issue arises when we are this concept arises when we use pointers. So if I make this not a normal variable, I make it a pointer variable. Okay, I make it a pointer which points to a specific location. Okay, model is a pointer, speed is a pointer. Then when you are running this program, then what you need to do is you need to use shallow copy or deep copy constructors, one of the two. So when you're using pointers in the default or the default constructor or the no argument constructor, what you have to do is you have to say model, you have to create this new int, you have to create a location for them, just dynamic location, that type of thing. Okay, so you create a model which is like a dynamic memory location on the, like when you run the program, it creates a new location. That's why we call new int. That's why we call it new int. So then we do the same for speed. We allocate a new location during runtime. Okay, also of integer type to speed. This is necessary when you are using pointer variables. Okay, for in the constructor. Then what you do is we do car at obj. So we have this default, we pass in the object model is getting passed into the current model, and the speed of the object is getting passed into the current object's speed attribute. Then we have this cout class copied. Alright, we have that message. Then in the main function we have BMW1. Okay, we created this object. Now when you're using pointers, you have this concept of dereferencing. So I access BMW1's speed variable, but I have to allocate 230 to it, so 230 kilometers per hour. But because this is a value, I have to dereference it. I have to dereference the pointer. Okay, speed, remember, is a pointer here, right? Speed was a pointer, model is also a pointer. So what I do is I dereference model and I dereference speed. Okay, and I enter these values inside of them. After that I have car BMW2. I created this BMW2 object, and I throw all BMW1's stuff into this BMW2 object. Basically I copy it over. Okay, and then I'm just say display the stuff, right? So now I'm gonna just display. By the way, I'm dereferencing all these values because they are no ordinary variables. They're pointers now. So you have to dereference to get the actual value at that specific location. So now I'm gonna compile this, and I'm going to run the program, and you can see that it gives us the message class copied. Okay, and it has BMW1 speed is 230 in kilometers per hour, model is 250, and then it took these values here, BMW1's values, and it copied it into BMW2, and you can see BMW2 is also the same as BMW1. Alright, now I'm just gonna remove this because it's unnecessary. So now it's not gonna say class copied. Okay, but now here's the thing. What we're using, this constructor, this copy constructor that we are using right now, is a shallow copy constructor, and what that means is that it does copy over the attributes, but it just copies like it doesn't make like a proper copy of it. Shallow means like not really deep. Okay, the opposite of shallow would be deep. So deep copy and shallow copy. So shallow copy, what it does, it copies the reference over, copies the address. So what this means, let me just illustrate. If I were to copy you can see BMW1 has been copied over into BMW2. Now the thing is, if I were to say BMW2 and I want to change its speed into say 320, okay, now look, I am only changing BMW2's speed, not BMW1's speed, just BMW2 speed. Now let me just run this. First compile it. Forgot to dereference, sorry, dereferencing mistake. Then once we actually run this again, you can see the problem. We changed only BMW2's speed, not BMW1's speed. However, here what it did is that it changed BMW2 speed, which is something that we wanted. We did that. However, it also changed BMW1's speed right over here, and this is something that we didn't change, but it changed that as well. Why did it do that? Well, this is called shallow copy. What shallow copy does is it just copies the address over. It doesn't create a new copy, it just copies the address, the memory location. So the location where, remember this location we created here, right? Model new int and speed new int. These are two different locations. Now the thing is that we created these locations, and 320, what BMW2.speed and BMW1.speed is referring to the same location in memory. Now when you change in the speed into 230, then BMW1's and BMW2's speed, they are both pointing to the same location which you changed. So you change that, now that's 230. So whenever you access BMW1, BMW2, you'll see that they're both pointing to the same location, which is 230. Then if I go there and I say access through BMW2 the speed location, I access it through the BMW2 object, I change it into 320, so it changed the 230 into 320, and BMW1 was also pointing to the same location, so it changed the main data inside that location which both objects were pointing to, and hence you have it shown that it also changed the speed of BMW1. This is the problem with shallow copy. It didn't really create a new object. However, in order to create a new object, you have to use deep copy. Okay, meaning if you change one variable, it wouldn't affect the other one. So I'm just going to use a clear right here, and I'm just going to run this once. So this is shallow copy. Right, now we're going to create a deep copy constructor. How do you do that? Simple. What you do is this: you take both of these, you copy that over, right, you paste it here into this constructor. So whenever you are dealing with model or speed, you have to create their locations. Okay, and then once that's done, then you're going to be using pointers. Okay, you're going to use a pointer here. So the model over here, you're going to put like that. You're going to dereference it basically. Okay, the model, and like that. Alright, now this is a deep copy constructor. So let's check the difference. So it has compiled. Let's just run it, and you can see the difference. BMW 1 speed is 230 and BMW 2's speed is 320. So what did we change? We only changed BMW 2's speed. We never touched BMW 1. So what this did is it kept BMW's 1 speed the same, which is 230. So what the deep copy constructor does, it is that it copies the object onto another location. It doesn't copy the address, it creates a new object. So it creates an actual copy, which is called the deep copy. So that's just the difference between deep copy and shallow copy constructors. Thanks for watching.